I got this power bank broken from someone. It's from that world famous brand Dexler, as we all know. It's a typical case. I've seen many brands with the exact shape and size. Here's the model number or something. Yeah, company, uh, 8000 milliamp hour capacity, 2 amp input, 2 amp output. Oh, 2.1 amp output. Okay. And what the problem was, I found it, of course. As you can see, can you see? Right there. Right there. This lead, the positive lead, or terminal, whatever you call it, it was broken. And the other one isn't in a too good situation either, but that one is intact. And this one was broken. So whenever you plugged in the charger cable, it would blink and test the battery, then couldn't test the battery, and so it switched off. So I soldered it, which is not a really good idea, but I figured that everything is insulated really well. So even if I accidentally touch the outer casing, that shouldn't make a short anywhere, because it's only the positive lead and this is insulated on the inside too. So yeah, I was taking my chances. I didn't touch it. It somehow I managed not to burn the insulation. So yeah, now it works. And the problem is that I still may have to abandon it, or how do I say it? Because the battery is not really great. When you charge it, it takes 6000 milliamp hours, and when you discharge it, it can only deliver 4000. So those are measured on 5 volts, but the difference is too large. I mean, 2000 milliamp hours lost in the air, that's how many percent? Uh, yeah, late night math. That's like 30%. Yeah, 30%. That is not typical of a good battery. These modern batteries nowadays, with the electronics loss and everything, should be around 90% efficient, meaning that you lose maybe 10%. Part of the part of the loss may be because it can only charge with 1 amp. So when you charge slowly, maybe it adds up more, but yeah. So this may not be worth saving. I will try out the electronics with 18650 cells, and hopefully that works at 2 amps. But let me show you why it broke, because that's the main focus of this video, to tell people that this has a major design flaw. So I pressed the button. So this logic board, or whatever board, the charging board, is held in with 2 screws, but whenever you plug in a USB cable on the output side or input side, it gets pushed in slightly, and these terminals were just straight. So when you press on a straight, this is not aluminium. So the lead coming out is aluminium, and it attaches mechanically without soldering, just clamping down to this. What is this? Nickel plate, nickel, whatever. So this is not aluminum, that's what I try to highlight. So it's a more it's a harder steel. So whenever you compress it, and then when you pull out the cable, you tension it, and you keep doing that for maybe 50 times. Just 50 times will eventually break it. And this broke off right here. And yeah, that's not a good solution. Uh, when designing this, you can see the battery is also not 200% length. And yeah, the battery can also move. Maybe you drop it or something and it gets pulled to the bottom, and then it also breaks. So my solution would be to just use two wires here. Flexible wires coming from the circuit board to the battery, and you solved it. Just use longer wires in a bow, or what do you call it, in a circle, half circle, and that would solve everything. You don't have to redesign anything. But this is really crap. This solution, just straight hard metal uh, terminals, that's a no-no. So yeah, whenever you're repairing battery banks or whatever you're doing, just don't use hard uh, metals like that. Maybe if you bend them up and then come down so they have some flexibility, so they can absorb the shocks coming from the constant plugging in and pulling out. Because yeah, that's the only solution here, because you can't stop this from bending. People, I mean, not just the people, it's not just user error, because this was designed that way. These plugs have to be manhandled sometimes. They don't want to get inserted too easily, especially when the device is new. Then it's the hardest to push in. So yeah, it's all only mounted on plastic, so it's 100% guaranteed that something will bend, not break, just bend. And if you keep bending metal, then it will break. So yeah, that's my long-winded explanation of this battery that I fixed. I don't know if I'll keep it in this form, but yeah, my other idea is to just put in like the size fits mostly. It will stick out a bit, but I can put like 1, 2, 3, 4, 5 of these in parallel and have a much greater capacity than the advertised 8,000, which now is call it 6,000 maybe. And I could have 10,000 with brand new cells. But yeah, I'll have to try out the electronics, if it can go up to 2 amps. If it can't go up to 2 amps, then maybe I'll put in a smaller battery here, but a new one, and call it a day. So yeah, tell me your experience with crappy power banks. Have you fixed any, or you just chuck them to the garbage and buy a new one for $2?